the standard Laplace and Fourier transforms, we also have other kinds of transforms, integral transforms, such as Manning transform and Hankel transform. They are used in different disciplines. For instance, the Manning transform, the definition of it is something like this. This is the original function, and we use this kind of integral to map the function from X domain into Z domain, if there is Z is given here. Again, we can use standard integral evaluation for this kind of problems. It can easily be solved. However, for inverse Manning transforms, it might be very difficult to find because this one is not easily transformed or computed by Matlab. So we have to use existing functions for Matlab. And I should not give too much detail in this Manning transform. If you are interested in, you can read the PPT slides and execute the functions yourself. And I'm not going to discuss Hankel transform either. So now let's consider a very special kind of transform, Z transform. Z transform by theory, strictly speaking, Z transform is not an integral transform, but it is quite similar to Laplace transform or Fourier transform. So I will present it here. And you know that Z transform is useful in discrete time control systems. And it will map the difference equations rather than differential equations into the algebraic equation. So let's see the definitions and the properties of Z transform. And this is the definition of Z transform. It will map the discrete sequence f of k into a function of z, where z here is a couplet member. So we can map from k domain into z domain. And these are the definitions and the properties, linear properties and other properties. And now the problem is, how can we compute Z transform, or how can we compute inverse Z transform? Similar to Laplace transform, we can easily find the Z transform by coding Z trans function or IZ trans function. The syntax is quite similar to the Laplace or Fourier functions. Now let's consider an example here. Suppose we have a discrete sequence described by this formula, where k is from 0, 1, and 2 infinity. Then how can we map this function, the sequence, into a Z transfer function, into a Z transform format? So how can we solve that? With the use of Matlab, we can solve that easily and straightforwardly. First, by declaring the variables as symbolic variables, and then exploit original function directly using this command. Then code Z trans function. And finally, you will get the result. And by coding that function, you can easily find the Z transform of given function. And the next question is, how can we find the inverse Z transfer function, Z transform to this function? It is useful in the analytical solution of difference equations. So if we can find this one, we can easily find the analytical solution to a difference equation. For this particular problem, we have to try different values for m, and we can implement it in loops. For instance, I is the same as m here. So I takes 1, 2, up to 8. And then we can find a series of solutions. There is a mistake here. We should use a comma or semicolon here. And we can find a series of solutions like this.
Okay. What is the function this? What does it this function?
DISP. Oh, display. Just if you use display, well, if you do not use this command, what you get is something like this: answer equals to the result. Quite annoying. So if I use display, just the display is fine. The result directly. I didn't mention it before. So from the results, you can summarize it. And you can see that all the results have a Q in the numerator. And this one in denominator, e to the power of n. And you can see that the sign of it is changing. So we can write something like this and plus 1. And also the coefficients. From the result, finally, we can summarize it and find the general form for the result for other m's. No matter what m is, we can extract this kind of formula from the result by m's. In fact, you can use this way to derive formulas.